Good day, I'm Raymond Henry Lacson Cruz, a student of UP Open University and currently taking Master of Information Systems. Today, I'm going to tackle parallel systems. On top of that, I'm going to compare parallel systems against network and distributed systems. Now, let's start our slide. Here's my picture. I'm the speaker. I'm Raymond Henry Lacson Cruz again. And here's a picture, my PhilHealth ID. Then, next is, I'm going to start now my discussion. Now, what is a parallel system? A parallel system is a system which allows several processors to execute instruction in parallel. It is designed for program execution, speed up, and fault tolerance. As you can see, here's an example of people pushing a car. Now, these people are doing parallel things with each other. They're continuously pushing the car in order for them to minimize the time that they will consume in order for the car to move. Imagine if there's only one person who pushes the car. If that one person pushes the car, it would accumulate too much time pushing that one. So again, that's the application of parallel system in the real world. Now, the next slide, we're going to discuss the parallel systems in our current technology. Now, our current technology needs parallel systems in order to satisfy the needs and the requirements of every consumer. Examples are high-end smartphones, laptops, and other modern devices. For the high-end smartphones to support their, let's say, modern functionalities, they need parallel systems. For example, a person or a consumer wants to play an online game. So if there's no parallel system, that online game will take too much time to be played. Now, here's a graph showing the parallel systems, the difference between a parallel system and a non-parallel system. So you can see, for a non-parallel system, an instruction or program will be only processed by one processor and will have its output. Yes, it will finish the job, but it will take 4 minutes to finish. Compared to a parallel system, as you can see, there are 4 processes who's doing the instruction that's been given. It only took 1 minute to finish that particular job. This is just an example, but as you can see, there's too much difference between those two. The time it consumed, and we can do so many things with the 3 minutes that we've been able to save. Now, let's compare the parallel system versus distributed and network systems. Now, what is a network system? A network system is a system that provides a network or data connection in order to allow interconnection between different set of autonomous computers. So you can see here's an example of a network. So you can see we have a router in the middle, and then we have the Philippines, US, and China connected on that particular router. As you can see, they can connect with each other since they are a network system. Next one is, what is a distributed system? A distributed system is a collection of independent computers that appear to the users as a single computer. Now we will enlarge the previous slide. As you can see, the router that PH, China, and US are connected with, we don't know what's inside of that particular connection or router, or maybe a cloud. So you can see when we open that particular router or cloud, we can see that there are file servers, web servers, and Active Directory and DNS server. So you can see they're being distributed on that particular cloud. So the user will treat that as just a gateway or a device, but in reality, there are so many devices interconnected on that one, and they provide services that we need. Now, let's tackle the differences between them. Now, parallel systems focuses more on the improvement of the processing power of a certain machine, while network and distributed systems focus on the communication and distribution of traffic on these devices. And in order to prove that a system is parallel, you only need one device that is capable of parallel computing, while in order to prove that a system is networked or distributed, you need more than one machine, physical or virtual. What I mean here is that in parallel systems, you only need one device to prove that it is a parallel system. For example, laptop that runs i7 and it's 7th generation, and it has multiple cores. So it's doing parallel system. But we don't see the network or distributed system on that particular laptop unless it has a virtual machine inside or whatsoever, or let's say GNS3 for network or what. But in reality, we only need one device to prove that it is a parallel system, and we need an interconnected set of devices in order to prove that it is network or distributed system. Next is I'm going to tackle the advantages of parallel system if it's being deployed on a network or distributed. It is possible to deploy parallel systems in a network system. It is possible by deploying load balancing capable routers in order to maximize the processing power while not limiting the amount of traffic that is going through. Deploying a parallel system in a network system will allow faster communication in a distributed system. If we have a load balancer that's capable of processing all the data and it balances the data that they get, they can easily process data that goes through them. So the traffic will be much faster, and the communication is also faster. Now, thank you for listening. Again, I'm Phil Cruz of UP Open University, and here's my references.